Hello, I'm Dr. Darren Simmons. In this video, I'm going to demonstrate how you can use Excel to complete part of the Principles of Statistics project Stage 2B. I should warn you that I am not going to go through the procedures for Stage 2B in their entirety in this video. Rather, what I'm going to do is demonstrate part of one of the major calculations that you will have to do in Stage 2B, with the understanding that you should be able to extrapolate from that demonstration how to complete the remaining calculations. Please keep in mind that it's important that you understand the formulae that I'm going to use here, and that you be able to apply them to details other than just those of this stage of the project. With that in mind, let's take a look at the Excel spreadsheet. So as you can see here, I've already included the raw data tab and copy and pasted over the raw data that I collected at stage 1. You can also see that I've already created the observed and expected means tab. 1 second here. Where I've also included a little mini table for the observed mean, which I calculated already. If you need a refresher on how to calculate the mean of your die rolls in Excel, I'll put a link to my stage 1 video in the description below. We'll also need to calculate the expected mean of the die rolls and then the sample standard deviation of our observed die rolls in just a moment. The expected mean of our die rolls will be calculated under the assumption that the die that we used in our experiment was fair. That means that every possible number that can come up on the die has an equal chance of coming up on any given roll. So the probability of the die showing a 1 is the same as the probability of it showing a 2 or a 3, and so on. Each has probability 1/6. There are 6 numbers in the die. They're all equally likely to occur. So each has a probability of 1/6. In view of that, we will calculate the expected mean in the following way. It'll be 1 times its probability 1/6 plus 2 times its probability 1/6 plus 3 times its probability 1/6 plus 4 times its probability 1/6 plus 5 times its probability 1/6 plus 6 times its probability 1/6, like so. Remember, when you're typing formulae into Excel, you have to start with the equal sign first of all. So 1 times 1/6. I'm inserting parentheses here just to be clear about order of operations. It shouldn't matter if you don't, but I'm just being a little bit more careful here. 2 times 1/6 plus 3 times 1/6 plus 4 times 1/6 plus 5 times 1/6 plus 6 times 1/6. And if you do that calculation, you get 3.5. As for the sample standard deviation, well, the function for that in Excel, you may recall, is called stdev.s, S for sample. And then we need to tell it to look on the raw data tab, which you do by typing in raw data in single quotes followed by an exclamation mark. And then the range where your die rolls actually are. And in my case, that was from B2 to B61. And so you get a sample standard deviation, or I get a sample standard deviation of about 1.86. To make this look a little bit more, table-y, I will format the cells by giving them a thicker outline and inline border. And also color the backdrop of the labels here yellow. Obviously, different colors, using different colors would be fine. The next thing we're going to need to do will be to create a tab for our confidence intervals. So this will be confidence intervals. I'm going to format the font to be Times New Roman and 12 point. I also like putting everything centered. I'm going to stretch out the tabs to be 225 pixels in width. As we'll see in a minute, that is going to be needed. Now, as far as calculations are concerned, I'm going to do the ones necessary to compute the lower bound of the 95% confidence interval only. And for that, I'm going to actually calculate the margin of error separately, and then the lower bound, oops, sorry, upper bound. Okay. So to calculate the margin of error here, I'm going to need to refer to a student's t-table so as to get the appropriate critical t-value. The number of degrees of freedom for the associated student's t-distribution will be the sample size minus 1. My sample is of size 60, so I will have 59 degrees of freedom. Of course, if your sample size is different than mine, then you will have a different number of degrees of freedom than I do, and thus a different critical t-value. Now, I'll link the table that I used to get this in the description below. As it turns out, the critical t-value that I wind up with is about 2.001. In order to calculate the margin of error, we multiply the critical t-value, which again was 2.001 in my case, by the sample standard deviation of the die rules, and then divide that by the square root of the sample size. So to get the margin of error, this will be the critical t-value, 2.001, times the sample standard deviation, which is in observed and expected means C2. So I need to be careful with how I'm writing this. Observed and new expected means C2. Parenthesize this, and then divided by the square root of the sample size. My sample is of size 60. So my margin of error looks like about 0.48 and change if we actually run this calculation. The lower bound of the confidence interval will be the observed mean, the mean of my die rolls, the ones that I got in my experiment, minus the margin of error. The upper bound will be the mean of my sample plus the margin of error. So I'll go back to my observed mean here, which is in B2 on this sheet. So I'm going to keep that in mind. So this will be observed and expected means B2 minus A3, the margin of error. And that gives me a lower bound for my 95% confidence interval. That is about 2.90 and change. The upper bound will be very similar. This will be observed and expected. I don't know why it keeps doing that. Expected means B2 plus the margin of error, which is in A3 here. So I have an upper bound of about 3.86 and change. From here, I will leave it to you to calculate based on your data the other two confidence intervals, the 99% and then whichever one that you choose where the level of confidence is at least 80%. One last thing to mention in this video. Before you submit your project, please be sure to address the question of why it is that you're doing the calculations that you're doing and what those calculations tell you about your die. And be sure to support any conclusion that you draw by making explicit references to your calculations. There's a saying, that which can be asserted without evidence can be dismissed without evidence. What that effectively means is that if you do not support the conclusions that you assert in the project with evidence. And in this case, that means making references to the calculations that you performed, then no one has any good reason to accept what you're saying as true. So it is important, therefore, that your conclusions follow from your interpretations of the available data. And so it is necessary to reference the data and the calculations that you did in order that that happen. That'll just about do it for this video. Thank you very much for your time. And if you need any help, let me know. Have a good day.